All right, so I'm going to start our last video of Chapter 5 with this thought. Just because there are the same number in each group does not mean you have paired data. I'm going to ask you to really watch out for that. Think about it. Be really careful deciding if you have paired data or not. If the data is paired, we're in Chapter 25. If the data is not paired, that means your two groups are independent. Then you're in Chapter 24. We're going to do an activity in class to try to practice telling the difference between these two things, but it's really important. All right, so going back to the story we were looking at last time with our physical fitness test, we were trying to determine if this exercise, device, and routine would reduce pulse rates. And so this time we're going to see if we can measure how much of a difference there is. And just to be like totally different, we're going to do a 98% confidence interval this time. That does mean it's going to be a little bit funky in our answer, but we'll go with it just to be different. So just to remind you, confidence intervals do not have hypotheses. So the first thing we go to is checking conditions. We actually did this last time, so I'll just remind you. Random, we discussed they were volunteers. So it does make it difficult for us to expand our results, but experiments are commonly volunteers. That's okay. And then we showed that the differences were not really nearly normal. I was pretty worried about that because we only had 10 in our sample. That's like really small sample size. Small sample size. So that means this thing needs to look really normal for us to proceed, and it doesn't. So I don't know. We'll keep going. We're doing what is called, last time it was a paired t-test. Today we're doing a paired t-interval. We'll keep going. So in our mechanics section, this should look really familiar because this is the same formula we used in Chapter 23. That actually makes a lot of sense. We don't have two sets of data, we have one. Remember, we took those two sets of data, we calculated their differences. So commonly this is called d bar, just to remind you that it's the average difference. So we're going to be filling in the items in this formula using our calculator. Of course, our calculator. It's very helpful. So my apologies, I'll show you where I got that. So if we go to stat and we go to tests, we're doing a t-interval. You'll notice there's not a paired t-interval, so we just remember it's the same. It's still a t-interval. You'll notice my data is in L6. Remember that was that difference list. And I actually am going to switch this to be that 98%. It's a little bit wider of an interval. That's OK. And then we'll go ahead and calculate. So here is everything I need to record. Remember, you don't have to write out this. But you do need to write out the interval with the numbers plugged in. So there's my d bar, same as x bar in the calculator, plus or minus. Remember, we get to write t star. We don't have to fill in the value. We just leave it. We're happy campers. Calculator did it for us. But I do need to include the subscript degrees of freedom, which is n minus 1. So 10 minus 1 is 9. And then I would multiply that by that 3.12 standard deviation over the square root of 10. And then all I do is copy the resulting interval from my calculator. I'm like, yay! So these two things, like, yay! Write them down. It's already done for you. Yay! This is weird. Negative? Because we widened that interval, we're getting negative values. What that means is our before minus after. Remember, that's how we calculated those differences? For it to be negative means this one is big and this one is small. So this value is showing me that, in fact, maybe it didn't work. Maybe it went the other way. OK, that's how I could get a negative difference. That's kind of weird. Could happen. So to conclude, I would say something like, we are 98% confident the exercise program produces a mean difference in resting pulse rates between negative 0.58 and 4.98 BPM. Now, if you don't feel comfortable putting a negative in there, like we could make it more clear, maybe more complicated. We are 98% confident, okay, blah, 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 produces a, maybe I'll say an increase, I guess I should say between, an increase of 0.58 BPM and a decrease of 4.98 BPM. I think that's harder to write, and I don't know if that makes more sense to you, but that's what I'm saying. I'm saying it's making anywhere from it actually made your heart rate go up half a beat per minute, or it made your heart rate go down 4.98 beats per minute. Ms. Curtis, why did you say up for the negative one and down for the positive one? Remember, it has to do with that big minus small. For something to decrease, it gives us a positive value. That's kind of funky, but we're into territory where we really have to think critically about what the questions are asking and which way we subtract it. Some people solve this by actually doing after minus before. And then it becomes a little bit more like the numbers you might expect to see. Just make sure you're thinking critically about what the questions are asking you. And that is the end of chapter 25.